This is evidence that the speed of light in near the sun versus away from the sun are different. But if you say that, you'll be fired.
Greetings to the brightest audience in the country. I'm Fred Williams.
And I'm Doug McBurney, Bible student, science geek, amateur comedian. Fred, it is great to be back with you for Real Science on Friday.
And we have back in the studio Dr. Pete Moore. And last show, we talked about all the problems with special and general relativity. We talked about things such as Mercury's perihelion. And it turns out that, maybe relativity works with that, but it doesn't work so well with other planets. We talked about the Heffley-Keating experiment with atomic clocks on airplanes, and it's often cited as proof of time dilation. And, Louis Essen, Dr. Louis Essen, a British physicist, he was one of the inventors of the atomic clock, and he had problems with that experiment.
He sure did.
There's a lot of issues with it, so we talked about that. We talked about E equals mc squared. A lot of people think that somehow that's related to special relativity. We found out it wasn't. And we also talked about quantum mechanics and how that is an evidence against special relativity and this whole notion that light is limited to a certain speed. You can't go faster than the speed of light. Nothing can travel faster than the speed of light. Well, quantum entanglement was a serious problem for that, and for years Einstein tried to disprove it to his deathbed, and he never was able to. And then later on, physicists actually proved that this phenomenon of quantum entanglement's real. So anyways, we talked about a lot of the evidences against relativity, but the problem is if you're going to try to poke holes into a theory, you got to come up with one of your own, right, Dr. Moore?
If you don't put one of your own, they'll just ignore your points of criticism.
Yep, exactly. So you've come back into the studio because we left the last show with our audience hanging because you've got you're going to propose a model, right? A way to explain the phenomenon that we've seen, and like the Michelson-Morley experiment that confused Einstein, and kind of rightly so, right? Because it gave results that kind of implied there is no ether. And so it led down this rabbit hole into physics of time dilation and, the size of objects changing sizes and all these kind of weird, crazy ideas. So you're here to help our audience alleviate this weirdness.
That's correct.
Well, Dr. Moore, before you start, I just have to thank you for confirming my suspicion for 15 years that everybody has E equals mc squared confused with relativity. Thank you. You proved it at least two different ways. And I just want to remind our audience scripturally. So Dr. Moore said you cannot replace something with nothing. You better propose a replacement or you're just going to be ignored. The scripture teaches us, in fact, Jesus Christ promises us that if we have faith in him, he will replace our old man, who is a servant of sin, with our new man in his image, who is a servant of righteousness. And so, Dr. Moore, keeping with that biblical theme, let's hear your replacement for the theory of relativity.
One of the things we did cover in our last session, we'll kind of go over that again. What did Einstein attribute his ability to be a free thinker and come up with some of these kind of stranger than strange theories? Well, in his autobiography, he attributes his positively fantastic free thinking, that's Einstein's quote, and suspicion against every kind of authority to having been deceived at age 12 by Bible stories taught in German schools. So that's where Einstein's coming from, is a rejection of the Holy Scriptures. But in spite of all of that, I still attribute his greatest achievement is when he finally came to the conclusion that there was an ether, and he did that 5 years after the general theory, but that the ether distortion actually creates gravity. And in that regard, in that little part, he's absolutely correct. And as we will find, that fits in very nicely with an alternate theory of the ether.
All right.
Yeah, and just to mention from our last show too, you listed all the scientists of the major foundations of science, and they're all Christian. And so somehow with all these disciplines, that the creationist community is going to trust a secular person who really rejects the Bible, in fact, was very critical of it. So that just something for our audience I'd ask him to consider, because that was one of the biggest reasons I have rejected relativity from years back. It was really just purely scriptural, based on the wisdom of the world as foolishness to God. And coming from Einstein, a darling of the media, a darling of the left media, Times Man of the Year multiple times. Anyway, sorry, Dr. Moore, I'll let you go on to your model now.
So we've criticized point for point, and as I've said before, you're not going to get rid of Einstein by just criticizing one point or another. You're going to have to replace it. So as we go forward here, I'm going to try to at least point to a possible theory of the ether model that could replace theory of relativity. Now, if you're going to develop an ether model, what needs to go into it so that you can consider it a robust natural physics model? And as we see here on the screen, the very first thing is that it must consist of real particles, mass, energy, and dimensions. So we're not talking relative stuff, we're talking real particles. 2, it must show the source of inertia, the resistance to acceleration. How is it when you go into outer space? Matter should be weightless, and yet it takes energy to make it move. That is called the resistance of inertia. And so what is it? A good model should tell you what that is. It must explain constant maintenance of velocity in space. So once you're up to a velocity, how is it you can then glide forever to the other end of the universe? What is maintaining that velocity? 3, why inertia resistance changes as the velocity of mass increases. It's not linear. And derive the mass velocity dependence equation. A good model of the ether should be able to do that. It should explain the mechanism by which light propagates. How does light crawl the next inch? What did it do to get that next inch? It should be able to explain or predict the speed of light, the actual number. I mean, it's an arbitrary number, 299,000, so such and such, all the way out, all those digits. Why that number? Why is it a specific number? The model of ether should explain the speed of light and predict it. It should explain why electrons and positrons can suddenly appear and disappear with a flash of energy. They call some of these virtual particles. They just all of a sudden popped out of nowhere. Well, I think a good ether theory will show you where they came from. It should be able to explain, predict E equals mc squared and its real meaning.
Oh, wait a minute. You mean it doesn't prove relativity?
No, it doesn't. And it has something to do with energy, but most people consider this the mass equivalent energy. So mass can be converted to pure energy or energy into pure mass. You're going to find out that's not true. There's a different meaning that explains that equation. It should be able to predict and explain Planck's equation for energy, E equals hf. Sometimes they call it V or italicized V, and its real meaning. It should be able to explain particle wave duality. We've heard of that in different parts of science, that there's a particle and wave duality. Well, what is the real meaning of that?
Yeah.
It should be able to explain the mechanism by which gravity force propagates.
Whoa.
How does a proton on the sun, single proton, reach out 93 million miles and tug on another proton on Earth at that distance. One proton tugging on another. And of course, there's trillions in the sun and trillions in the Earth, but they do it one at a time. How does gravity do that? Number 11, it should explain or predict the Michelson-Morley experiment null result. And that's no easy feat.
Yeah, and go back to the last show to learn more about that. I believe Dr. Moore has a really good explanation there.
And we're going to fill that explanation in further in this session. And then number 12, it should be able to explain and predict the gravitational constant itself. Why is it those digits 6.6743? Where do those digits come from? And right now, I've seen some things on the YouTube that said the gravitational constant is the biggest mystery of the universe. Nobody knows why it is that number. I believe that a good model should be able to predict that. Now, you notice I have number 12 in green, and underneath I'm saying in progress, still working on a mathematical solution. So the model that I'm going to show you, the first 11 are already done. The only one that is yet to be done is number 12. And the author of that model was working on it before he passed away, but he didn't finish his work.
Because here's the thing.
Anyone out there in your audience would love to be famous for the next 100 years is take the model of ether and show algebraically or with calculus and differential equations how that you can derive the gravitational constant G and get it right.
Well, and whoever nails that math, they have the equivalent of E equals MC squared on the walls of every university for the next several centuries.
There you go. Now, there are some other names for the ether, or ether space, or the vacuum space. There's some other names for it. Now, we know that it has electrical properties and magnetic properties. We've already mentioned that before. So it's no surprise that the other word for an ether is the electromagnetic field. Well, what's a field? Well, it's a field. Nobody wants to go into how did the field get there? What is it made of? What's its granularity? All of those, it's just a field. And so it's like saying ether. So if you like the word ether, great. Or you can call it the electromagnetic field. But when we look at that word, electromagnetic field, it's made of two parts. Electro is talking about electricity. And those come in two flavors. The one flavor is a positive charge. And when we talk positive charge in our universe, the only things that we know that are fundamental are the positron and the proton. Now, the proton is about 1,800 and I think it's 36 times bigger than the positron, but both of them have the same positive charge. So electro comes in positive, but it also comes in negative. With the negative charge, the most famous, of course, is the stable electron. And so those are particles that have those kind of charges. Now, we have the other word, magnetic. Magnetic always comes in two flavors, North Pole and a South Pole. And anytime in the universe you find a north, you'll find the south nearby. So they always come in pairs. Unlike the mass, you can have a positron or you could have an electron. They don't come in pairs, but these come in pairs, north and south. And so if we look at that and we take the north and south and consider that each of these particles has a magnetic dipole. So positrons and electrons are known to have a magnetic dipole. They have a north pole and they have a south pole. And why shouldn't they? They are spinning charges. And if you take charges and make them move, you create magnetism. So these spinning particles have their north pole and their south pole. So when you do this kind of a study, you can see that if the ether is made of particles, these are most likely the particles that the ether is made from, because now they possess both electrical and magnetic properties.
Yeah, and from my engineering background, electrical engineering is whenever you have a current, you have magnetism. So that's why we've talked about plasma cosmology as something we think, maybe more creationists should look into. And we've done a radio show on that, I think 3 years ago, Doug, but we're gonna do another show for the YouTube audience on plasma cosmology. It's something we find interesting. We're not 100% convinced of it, but to your point, the universe, there's so much evidence showing, this the electromagnetic, these currents running through the universe. So interesting. That's really cool.
So, with this kind of an understanding that if there are likely particles that make the ether, we've identified most likely what they are. So, we go back to the postulated ether theory, which we've already covered, but I want to add two more things. One, the extreme light speed through an ether suggests that the ether is highly elastic and highly stiff. How fast are we talking about? Speed of light, 186,000 miles a second. Well, if you take an energy wave through a pad of rubber, you knock on it with your fist, it goes a certain speed. But if you, instead of that, you take a slab of steel, it's stiffer. And then when we measure the speed of sound through it, it's many times faster. However, if you take a diamond and measure the speed of a really stiff diamond, which is far even stiffer than steel, it's faster yet. So then the theory goes, well, then what would explain the speed of light, which is 10,000 times faster yet? Something extremely elastic and extremely stiff. And so we would need to recognize the ether must have those kind of properties.
Well, Dr. Moore, can you stop for a second? Because I'm just from the layman's point of view, it seems to me that elasticity and stiffness aren't those like opposite of each other, or am I misunderstanding?
No, elastic means it's stretchable. Stiffness means how much energy it takes to stretch it. So elastic stiffness has to do with the energy of elasticity, and something that could move an energy wave through it at the speed of light would have to be enormously elastic and enormously stiff at the same time. Newton suggested the unknown, or an unknown vibrating ether particle. So Newton came back and said, I think it's particles. I think the ether's made. Now, he didn't know what they were, but he certainly said that's what they are. And why shouldn't he say that? All other energy waves have a particle medium that waves. We have water waves, gaseous waves, solid waves. All of these are similar in that they have particles that make up the medium, whether it's water or air, or if you were to take that salt crystal there and bang on it, the sound through it is even faster yet on that stiff salt crystal. So we have water waves are repetitive cyclical motion of H2O atoms or molecules, and water sound waves are repetitive vibrations of H2O, and we have salt sound waves are repetitive vibration of salt atoms, and a diamond sound waves are repetitive vibrations of the carbon atoms that make up the crystal. So all of this would seem to indicate that if you're going to have waves, then somewhere something has to wave, and particles are a logical conclusion. The stiffer the bond energy between the particles and the lighter the particle is, the higher wave speed you get. Now, Scientific American addressed this possible ether theory of Sir Isaac Newton. And here's what it says. Isaac Newton was convinced that there must be an account of gravity, and he attributed it that it must be teeny, invisible, jingling particles filling all of seemingly empty space. There it was. He said the entire universe is made up of jiggling little tiny particles. And that was his best shot at explaining an ether model that would account for gravity.
Okay, well, how did he do?
Well, Newton wrote about an ether model and gave many of the details of its component attributes. And so let's look at what he wrote. So here we have in this book, Newton's Philosophy of Nature, page 143 to 144, and question 21. And here's what Newton said: and that the elastic force of this medium is exceedingly great, may be gathered from the swiftness of its vibration, like the speed of light. If anyone should suppose that ether, like our air, may contain particles which endeavor to recede from one another, in other words, vibrate, for I do not know what this ether is. Well, the electron had not been discovered.
No.
The positron hadn't been discovered. That will be hundreds of years later, and so it was several hundred years. So he had no clue what they were, but he still came to the conclusion it has to be particles, and that its particles are exceedingly smaller than those of air, or even those of light. The exceeding smallness of its particles may contribute to the greatness of the force by which those particles may recede from one another, and thereby make that medium exceedingly more rare and elastic than air, and by consequence exceedingly less able to resist the motion of projectiles, and exceedingly more able to press upon gross bodies by endeavoring to expand.
That's amazing. This is from 1687, roughly. Wow.
So he is telling you the attributes of ether that it would have to be to account for all of this. And he continues on. And may not the planets and the comets and all gross bodies perform their motions more freely and with less resistance in this ethereal medium than in any fluid that fills all space adequately without leaving pores, and by consequence is much denser than quicksilver or gold? And may not its resistance be so small as to be inconsiderable? For instance, if this ether, for so I will call it, should be supposed 700,000 times more elastic than our air, and above 700,000 times more rare, its resistance would be above 600 million times less than that of water. And so small a resistance would scarce make any sensible alteration in the motions of the planets in 10,000 years. So he has now got an ether extremely stiff, extremely elastic, and yet the particles so light they won't even resist whole planets moving through space for thousands of years and millions of miles. And that was his model of the ether. So what I did is I took his model of the ether and I took the list of what he says it needs to be. And then I asked myself, is there any modern model that would meet all of Newton's requirements? And the answer is, there is. And that's the model I'm going to present to you as my best guess as to what the ether is. And it is this. This is called the Epola model by Professor Simhony out of Israel. He has since died, but this is his model. And we look at these particles, and we're only, of course, looking at one cube. It fills all of space. And note that it has electrical properties and magnetic properties, which we've already said, because look at what it's made out of. There's an electron, the blue dots. The red dots are positrons. Mm-hmm. The positron and the electron have now been discovered since Newton. They have electrical properties, and when those come in near each one, the bond is tremendous, so it's a highly elastic bond between them. Also, if you'll notice that the positron has a north pole and a south pole, it has a magnetic moment. So does the electron. It has a magnetic moment. So there's the properties that we need. We need electrical and magnetic properties of this ether that we call space. This model would provide all of that. Mm-hmm. And Simhony has put how far apart those particles are, 4.4 times 10 to the minus 15th meters. So that's about 50 times the diameter of an electron. So an electron or a positron, you can look at that space in between. You could put 50 more electrons and positrons between them. That's the space that he came to, and by studying salt crystals. Now, when we look at what Newton has said, it's exceedingly great. The elastic force is exceedingly great. When you compare that to the elastic force of air, this model is 13.2 million times more than air. Newton was looking at the swiftness of its vibrations, like our air may contain particles, and that vibration, well, this would have 904,000 times more, this model. Exceedingly smaller. The electron is much, much smaller than an oxygen atom or an oxygen molecule, O2, or nitrogen, N2, by 52,000 times.
Wow.
Exceedingly less able to resist the motions of the projectiles. This model is purely elastic. So any energy it takes to get into it and move through it, you get it back as you move through it. So it restores the energy. And Newton here is showing it fills all of space and is much denser than quicksilver or gold. In fact, this would be 550 million times more dense than gold. So if you could take a cube of this out of the ether, pull it out, put it on a weigh scale on Earth, you would find it's 550 million times the weight of the same volume of gold.
Okay. So you mentioned virtual particles before. Have you considered this in light of like 0-point energy? All these new ideas that are coming to the forefront.
That is right. Instead of virtual particles, we now have real particles. They've been discovered. We know the properties of them.
Yeah. Yeah, I can't remember the names of all of them, but I know like there's one in the news here recently, muons. I'm not even sure if I'm saying
Muons.
Muons.
Yep. The Higgs.
Yeah.
Also, with mass and density and charged particles, you can use the existing solid-state physics equations for energy wave velocity. We already have that for salt crystals, diamonds, you name it.
Right.
Take that same equation, apply it to this right here, and guess what pops out? Do you recognize that number?
Huh.
Speed of light.
Well,
Here's
so
a
now-
model
Interesting.
that when you take this model with that 4.4 distance spacing, put it into the existing solid-state physics equation, it says this thing is so stiff that when the vibrations go through this crystal, they will be going at the speed of light. That's not an accident, folks.
No, and so Dr. Moore, for people who are looking for strange and weird, because people like strange and weird things because we like to be entertained. So you're basically saying that we've got something denser than gold and stiffer than steel that fills the whole universe, and we don't even notice it.
And you're swimming in it.
That's weird enough for me.
And you don't even know it. But
Yeah.
You know what? The fish swimming in the sea don't know they're in the water either.
There you go.
Let's explain how he got this model. He was studying salt crystals, and in the laboratory, if you take a salt crystal made of sodium and chloride, each of those has a negative. One has a negative charge, the chlorine, and the sodium has a positive. So the chlorine is pulling away more of the electrons, and so it's negative. And you have this ionic crystal, and as you notice, the electron is a negative and the positron is a positive, so there's your antithesis in a salt crystal. However, he noticed that in the laboratory, when they hit the salt crystal with a special beam of light that is exactly the energy of 8 eV, it separates some of the atoms and the salt becomes opaque. So you see, I'll go back and let that happen again. Now watch kind of as it hits, and then it suddenly starts going opaque. See that cloud? That's because those have come out of the crystal and they're free flowing and you can see them. and it makes the salt crystal look opaque in color now, not clear. Then if you take the beam away and wait just a few seconds, all of it starts to go back together, the cloud disappears, and all the atoms find their original place in the crystal. So
virtual particles.
These are, these are virtually real particles.
Yeah, exactly.
So we know that the light beam does not create a sodium and a chloride atom. It separates what's already there.
Interesting.
It separates what's already there. So in looking at that and understanding that as what he was studying, he then compared that to this situation. Carl David Anderson, who discovered the positron in 1932. How did he discover it? Well, he took a light beam, 1.2 million eV, so not 8 eV, 1.2 million eV, much, much stronger, and he pointed it right into empty space. You know, where at one time Einstein said was nothing.
Nothing, yeah.
Well, you point this particular beam at nothing, and out pops an electron and a positron, real particles with real mass and real properties of charge.
Wow.
Then when you take the beam away, watch what happens.
Out of there.
They go back to invisible with a flash of light. Did you see that?
I did. And so that's, this looks like virtual quote unquote particles.
Right. What we talked about on our show about plasma astronomy.
Yeah,
so Dr. Simhony looked at that and said, that's the same thing that happens to a salt crystal. It was clear. All of a sudden we can see things. We take the beam away and it goes back to clear again. Maybe that's what space is made out of. And so he came up with, this is what's happening. The light's not creating particles. It's knocking particles that are already in bond together in the crystal. So now watch this. Here's the beam. It hits the bond, knocks them out. Take away the light. Flash a light, they come back together. They go back together. It took energy to get them apart, but they bring back that energy when they go together. And that's the flash of light we see after that beam is taken away and things start coming together. All of a sudden, light flashes. He said, so E equals mc squared is the bond energy of these particles. It doesn't create particles. It just takes the bond and breaks them. That's the real meaning of E equals mc squared. And he called this the electron-positron lattice, for short, Epola. So you can do some things on the internet and search for Epola, and you might find a few things.
And, just quickly, I know that Barry Setterfield has talked about, expanding the heavens and the elasticity and, creating energy like you do with a rubber band. You stretch it and there's just more energy accumulated. Well, at the beginning, if there was a lot lower, like 0-point energy, maybe light could have traveled faster at the initial creation.
Absolutely. And what we will find as we go through here is that the distance that you see, he has got a distance between particles of 4.4 times 10 to the minus 15 meters. If that distance gets smaller, the string, it's like two magnets getting closer together. Pretty soon it's so hard you can't stop them from going all the way to close. So it gets stiffer as they get closer. And it gets stiffer more as they get closer yet. And at the beginning of the universe, before he put all the other mass into the universe, this thing could have been very condensed. And the stiffness of this crystal could have been 1,000,000 times stiffer than it is today. Which means light might have gone 1,000,000 times faster at the moment of creation in those early days.
Like the earthquake.
At least we have now a mechanism.
Sure.
Humphreys, at one of the creation conferences, suggested that light in the early days of the creation could have gone millions of times faster than it does today, but he had no mechanism.
Right.
The stiffness of this crystal could account for it. Now, Simhony picked 4.4 times 10 to the minus 15th by comparing the electrical properties of these positrons, electrons, and comparing those to a salt crystal, which is the closest we can get of having also ionic bonds. And so he came up with 4.4 and showed how he calculated that. However, in Houston, our creation, Greater Houston Creation Association, we had a member that said, I think with that Coulomb force, we should be able to calculate that directly by going to the equations of Coulomb force attraction. So to check Simhony's 4.4, he did it a different way. He said, now look at the top of the screen and you'll see an electron and a positron at infinity. And he says, if those come together, will they completely go to zero? Will L sub 0 be 0 and they annihilate? Or do they come close together and stop for some reason, which means they didn't annihilate, they made a bond and a crystal? So that's the question.
Okay.
Based on what we have measured, that burst of energy and what it takes to break the bond, what would we then predict? So he put this.
So before you go on,
Sure.
Dr. David Grysom.
Dr. David Grysom, PhD in electrical engineering, is the one who decided, I'm going to check Simhony's lattice spacing. I think I can do it with the laws of electrodynamics and the force laws, the Coulomb force laws. And so that's what he's doing. I'm going to take you step by step of how he did it.
Well, wait, and this fella, David Grysom, he's a creationist.
He is a creationist.
He's a Christian.
And he has been a longtime member of the creation group in Houston. He is now retired, and he has some real health issues that are occurring, and so he can't go to our meetings anymore. But he's the one who actually made a presentation, and he showed us his math to check Simhony.
So I just want to make an official note here on Real Science Radio that here we have another Christian creationist who asks the best questions. Christian creationists ask the best questions. That's why they're the fathers of so many of the physical sciences.
Of all of them, basically.
And this was a kind of a flash of genius by Dr. David Grysom.
Yeah.
And he starts with the well-known equation for Coulomb attraction, force is equal. And now watch what he does to it. He says the binding energy is equal to the work done to bring charges from infinite separation to some lattice spacing of L sub 0. Now, if they annihilate, L sub 0 is 0.
Mm-hmm.
And that's what Einstein and everybody claims, is that the electron and positron create pure energy and annihilate. Well, this will prove whether it annihilates. If you get 0 for L sub 0, then they annihilated. If not, they didn't. Well, he shows work then is force times distance, so he sets that up as a summation. This is the summation of the small elements of work done for small changes in the distance of the separation, and he's going to integrate from infinity to some unknown value L sub 0, which he's going to solve for. So the only unknown is L sub 0. Everything else is already known. Let's plug it in and see what it does, is what he's saying. So he then takes the integration, works the integration down, and he ends up that if you're talking empty space, this is the equation. When you apply this equation, it does not go to 0. However, this equation is if there was no Epola, there was no ether, it's just empty space. Now you have to convert this, and this is the work that I and several physicists in London put together. We said, what he's done is perfect, but when you look at Simhony, he tells you that the Madelung constant is needed for salt crystals, and so we added the 1.75 for the Madelung constant, and for the short-range repulsion force of salt crystals of 0.9, you have to add that in. Now you've converted his equation to a crystal equation. And then you have to solve that equation for L sub 0. L sub 0 in that equation is the unknown. Since the binding energy has already been measured, has been known by the guy that found the positron, you look at those energy levels, convert them to joules, and that's for 2 particles. These equations work on the energy per particle. So you have to then go to 1 particle. So it's 0.511 times 10 to the sixth eV per single particle. Then you convert that to joules. So there's your energy in joules. Then take that energy and put it into that equation. Thus, we can solve for the Epola lattice spacing. L sub 0 then would be equal to this, and that's equal to all of those parts, which equals 4.4454. Simhony said it was 4.4 using salt crystal analogy. Dr. Gryom and then the physicists with myself and others who converted that all to a salt crystal showed he got it right.
Yeah, that's really impressive.
So this is some impressive mathematics that uses some integral calculus and things of this nature. But guess what? We have a real Epola with a real spacing here. And we can start down on it.
And this math is based on observable experiments that have been done. This is established reality.
That is correct. We know how much light energy is required to make an electron and a positron pop out of absolutely nowhere, the vacuum space. That is a known, and that known is in this equation.
Right.
So once you plug it in and then solve for L sub 0, you find out those two do not annihilate. They come together and then they stop a certain distance apart, creating an ionic crystal. Very, very stiff, very, very elastic. Nikola Tesla said this: light can be nothing else than a sound wave in the ether. This guy's highly respected for all the patents that he's done.
Oh, absolutely.
The alternating electric motor.
Yep.
Yes.
He's a genius. And this is what he had to say about light. It is a sound wave in the ether. And then he goes on to say, in an article that was picked up by the New York Times back in 1934, that article says, "We have made sure by experiment," said Mr. Tesla, "that light propagates with the same velocity irrespective of the character of the source. Such constancy of velocity can only be explained by assuming that it is dependent solely on the physical properties of the medium, especially density and elastic force." Now notice, he puts it solely on the physical properties of the medium, not on the speed of the observer that was watching it.
Right, right. And we have to keep in mind that while Nikola Tesla did have some fantastical ideas, he did come up with radio and alternating current, real things that really work to this day.
Absolutely.
And look what he says in this quote here that you're sharing with us, Dr. Moore. "We have made sure by experiment." So I want to say something else that Nikola Tesla said. He, quote, "Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality."
That sounds like the Sir Isaac Newton warning.
It sure does.
Right?
In different words.
You got to go back to our last show to find out what that Isaac Newton warning was. But man, doesn't this sound a lot like the special theory of relativity, wandering off after equation? So good stuff.
Now let's go look at what he said. I'm going to circle a word here. See the word density? What is density? Density is mass per unit volume. Mm-hmm. So this ether that he's talking about here must have mass per unit volume. And guess what? Look at the word mass. What is mass? Look in our universe today. Show me something that's mass. It's always a particle. Mm-hmm. Excuse me. We've got back to Simhony's particles, haven't we? By another method, by another man, it's implying particles. This is a YouTube video screenshot of a group that studies wave theory, energy wave theory. And they have some excellent things. And this was one screenshot I took. And in it, they say the equations of energy wave theory require a density constant to accurately calculate particle energy and force. Without it, the calculations are not even possible. Look what they say there. I'm going to blow it up for you. Boop. Density properly implies waves traveling in a medium with given mass per unit volume. We got back to the same thing that Tesla said. What is mass? In our universe, anything you can show me that we can weigh is a particle. Period. So these people are strongly implying that whatever this ether is, the equation itself is pointing you toward mass and particles in a unit volume, and you saw the beautiful unit cube that Simhony has for it. If you want to look at more of their stuff, I'm not trying to steal their stuff. I'll advertise it. Here's their YouTube link. You can go there, and they have many very good things on energy wave theory, but this is one of them. Now, we've got to go back and find out. We couldn't use the entrained ether. We couldn't use a rotating ether because of the problems. I'm going to now suggest the solution to that. There's another one. So we got the same Earth. We're going to send it off on its course. But before we do, remember that the blue in this picture is the ether. And Simhony is showing the ether can be contaminated by a nuclear particle. Well, what's a nuclear particle? Well, every atom on planet Earth, whether it's sodium or chloride, has a nucleus. Those nucleus are real tiny, and they actually can go inside this Epola cube. There's always 8 to a cube, and the nuclear particle can get in. But when it goes in, notice what's happening if you get bigger and bigger mass particle. You see it beginning to distort the Epola. The Epola is distorting and getting a higher volume once that particle gets inside it. Here's the Epola 2D with one of the particles in the middle. Notice the distortion. Remember, well, let's cover this first. Mass is an inclusion in the ether. It is taking pure ether, and then you stick something in it, that becomes an inclusion or a contaminant, but it also distorts the ether and lowers its density in that little region. So we're going to send our Earth on around the sun. Before we do, I want to go back to Albert Einstein. Now we've given him a few black eyes so far, but I don't want to underestimate what he really has done. And one of the things you have to give him credit, he finally said there is an ether. He does allow a distortion, which is a movement of that ether, and you can see the movement above, creates the gravitational field. He said distortion of the ether then, or the distortion of space, is what creates gravity. And I believe he's absolutely correct, and it even is in accordance with Simhony's Epola model of space.
So you're saying it's not time dilation.
Right. I'm going to let the Earth create a gravitational field in the ether where now watch the rotating Earth. It'll kind of turn a bubble of blue. That bubble of blue is the distorted ether.
Okay.
So it is creating in the volume of the mass of the Earth a part of the ether that is totally different than it was. The Earth mass distorted the ether. And that distortion stays with the Earth. When the Earth goes, it's not dragging the ether, it's dragging the distorted shape of ether.
And that's going to get you the null result.
And that is exactly right. You're thinking beyond me, and that's exactly right. This particular distorted ether is different than the ether all around it. It travels with the Earth, and therefore the Earth is standing still with regard to its own gravitational ether field.
Yep.
Does that all make sense?
It does.
Well, so number one, if that's not weird enough for you, you're just too weird, okay? That's weird enough for me. But does this explain why it appears gravity propagates instantaneously.
Gravity does not go instantaneously. Gravity is thought, even by secular scientists, to travel at the speed of light. And it actually should travel at the speed of light because the same ether controls the speed of light. And so it also is going to control the reactions of gravity.
Okay.
So now we go to the professor from Colorado University, Mr. Beckman, on page 28. He said he disagrees with the entangled or entrained ether, where you jerk it out and drag it around or rotate it clear out to who knows where at thousands of times the speed of light or millions of times. He said it's not entrained ether, but it's local gravitational field ether. He and Einstein are almost laying on top of each other here.
Yes.
But in doing so, Einstein never told you what the ether was, and he's waiting for you to figure out one that could follow the Earth. So he didn't know about this. This is the solution that actually knocks his theory right out of the ballpark.
Exactly. And this Peter Beckman from CU, he was a critic of special relativity, but he wanted there to be another competing model.
And unfortunately, he died before Simhony had put forth this model. He would have been elated to know that the model of Simhony gives the gravitational field he talked about, because he knew if you could go with the gravitational field ether, it solves the Michelson-Morley equation.
Yep.
Solves the MMX mystery. Now, this distorted ether is going the exact same speed of the Earth. And now when you do the light experiment, you will get the right answer. Right. Now, to show you how a nuclear particle goes through the ether, it does so frictionless. It's like if you look at a frictionless bearing. What's the best frictionless bearing we have? Take two magnets, North Pole, hold them together, rub them together. They slide apart. They don't want to touch, and they don't generate heat. They actually push apart, and that is frictionless. So this nuclear green particle is now going to go through the ether, the Simhony ether. Now get this. As it goes in, it takes energy to force that electron and positron apart. They are strongly adhering to one another, but as it passes it, they come back together on the backside and give it back the energy it took. So once it's moving, it will move forever.
Okay.
And so this seems to be getting at the light, the wave particle duality, and how we think we're seeing a photon pop out of. Am I
the
going
wave particle duality is when that little green particle goes through, it's actually opening, before it gets to the particle is already opening up and setting up a wave motion in front of that green particle.
Okay.
So your wave duality is that it sets up a wave in the ether. Before it quite gets there, it opens it up so that it can get through. And once it gets through, it imparts the energy back so it can go the next inch.
Right. So photons aren't popping out of nowhere.
That's correct. Now look at this. We have here a 2D model of the ether, and let's take a helium nuclei and bring it in. Ooh, an alpha particle. See how that spread them apart?
Yep.
The ether distorted. When you have mass distorting the ether, like Einstein said, it creates gravity, and I'll show you that a little bit later. This produces gravity, as we shall see. I will get to that. If you look at a cube, now it's kind of a 3D. Think on each of those corners an electron or a positron all the way around. And now, let's look at a 2D slice of the ether, or the Epola, and I'm going to create a inclusion in one of those right there. Now, with one piece of mass, the particles on the left and the right, they're trying to pull together, but through that dotted line, they're actually touching one another, like with a magnetic push-off.
Mm-hmm.
On the right and the left side, what's the distance, vertical distance between those? Are they the same?
No.
So to the right and the left of that big black thing, the vertical distance is a certain thing, and on the left side, it's about the same. You make a perfect square. See that perfect square around it? So in this case, there's no net force that's bigger on one side than the other in the horizontal direction. But watch what happens if I put a second particle. What happens? Now look at what happened. On one side of each of those black dots, it's tall or further apart, meaning weaker. And on the right side of that right one, it's smaller. Now you have a net different Coulomb force. Now you have a differential. And where they're closer together is stronger. It's going to push that particle on the right to the left. And the left particle, if you go to its left, that's closer together than the one in the middle. So both of these is going to create a push force driving them together. It's the differential electric force based on those trapezoid shapes that is now encompassing each of the particles.
Okay.
You don't have it if you have one particle, but you do when you have two particles.
And this is tension forces.
Right.
Okay.
Some people say, "Why those dotted lines and the frictionless? Are you sure that's science?" Well, look this is exactly what Maxwell wrote. He has a magnetic field circle and electric field particles that he thought were like ball bearings. All I have done is taken the electric one and put it in the middle of the big one, because the spinning electric is what makes the magnetic.
Mm-hmm.
Yep.
So when I go back here, my red and blue dots are in the middle of that magnetic field, and his are kind of on the outside. But he had the same kind of an idea.
Yep.
Yeah.
And if you want to study a little bit, there's the link. Now, if you look at it, zoom way out and look at it of all of space, if we have a particle, green represent low pressure or low density around that particle where the Epola is expanded. The purple is representing more dense. So if you sum up in this direction all of the various layers of pressure and compare that force of those pressures to the other side, they're the same. They're symmetrical. Up and down, they're symmetrical. The particle is not going to move if there's just one particle in the distorted ether. The green is the distortion, and then there you have it. Net force is zero. The object will not move. But when you have two of them, and you bring them somewhat close together, what happens in the middle is turning greener and greener in the middle. And now, when you sum these, you get a net difference. Same thing with the other particle. You get twice the green in between, and so it has a net force. And now the two can begin to come together. The equilibrium and non-motion has been reestablished. So it's just another way to do it. Now we know what gravity is. Distortion of the ether creates an offset electrical force that pushes those particles. Now, Einstein drew the expanded space, and this is one that's on the internet. But when you look at his grid, expanded grid, and he's not showing you the one that goes inside the Earth, just the stuff that's on the outside, you get this. The question is, what is the grid with Einstein? He doesn't tell you the grid. Mm-hmm. When I ask AI, what is the space of the space-time? It says it's not physical.
Right. They basically, it's nothing.
So we're back to Isaac Newton's warning. Yep. What is the grid? With Einstein, there is no grid. He said, well, I do accept ether, but he didn't tell you what the ether was. Simhony tells you the grid is the Epola particles.
Yep.
That's the intersection where those grids are intersecting. That's where the particle is. And the particle can be expanded due to the Earth's mass. And that then causes gravity, which then can allow the moon to use that gravity and begin circling the Earth.
Yeah, so you have the gravity, which is a weak force, but this explains how you can have that happen. Interesting.
Yeah.
Okay.
So at least Simhony also agrees with the expanded Epola for gravity. Einstein is saying distortion is gravity, and we got Peter Beckman saying the same thing.
Mm-hmm.
But Einstein throws in time.
Yes. You got to take time out of it, go to regular space. You didn't need this kind of complex thought thing of time somehow and space are all together. They're separate entity. But when you go to space, he got it right. Distortion of space creates gravity.
Okay,
Also,
and the addition of time, the addition of time that Einstein insisted that time and space are a fabric.
Right.
Right? Okay, so that insertion of time into that whole thought process, that was like one step too weird. That was not necessary. Okay.
And you're exactly right. It was one step too weird. Had he just pulled back on the time part, he'd have got it dead right.
Yep.
And I do have to give him at least that. Distortion of space is gravity. Okay. Also, distortion of space affects the speed of light. As those particles of the Simhony model get closer together, light goes faster because it's stiffer. Well, where the sun is, you see that green? That's expanded. Now the particles are further apart from each other and they can't vibrate because they're less stiff. As you go away from the sun, it gets more compact, and that's where light can travel faster. So light, according to this model, is not a constant. And if you go far out into space, you might find light traveling faster based on this model. So we have slower speed around the sun, and we have faster speed in the outer regions away from all this gravity. Guess what they found? Professor Erwin Shapiro, Harvard, he was the first to notice the unexplained time differences in the Mariner radio signals between Earth and Mars. He assumed it to be gravitationally caused time dilations, per Einstein's theory. But what was really happening is that the speed of light wasn't constant. That's why the signals sometimes were getting to the Earth too fast, and sometimes they were getting to the Earth too slow. You didn't have to go to some abstract time slowed down type thing. Mm-hmm. Let's take a look at how that happens. When you send a signal from Earth to Mars, it goes near the sun. As it goes by the sun, in that region, it's expanded. So the path, if you wait, say 6 months or a quarter of a year, now they're in this. Now when the light signal goes to Mars and back, those radio signals, notice they don't pass near the sun. They're further away from the sun. The further away from the sun you are, the more compact those particles are, and the faster they vibrate, and the faster light goes. Yep. So now let's put it all together. Notice when the Earth is nearest the sun, the light, the time to get to Earth is smaller. As you go the other way, the path that is furthest from the sun, or further from the sun, took less time. And if it's close to the sun, it took more time because light was traveling slower. It took more time. This is predicted by the Simhony-Epola model.
And this contradicts a constant speed of light.
Exactly. This is evidence that the speed of light in near the sun versus away from the sun are different. But if you say that, you'll be fired.
Yeah.
So rather than say that's logical, you say, it must have been a time dilation.
Time dilation.
Oh.
Wow.
So now we see the time the time difference. It's really attributed to the speed of light based on a real model of particles that exist.
Right, and just to make it clear, the less dense ether around the sun causes those radio waves to travel more slowly. They take a little longer to get to Earth.
Exactly.
Once we get out into space that's not disrupted by an object, you get faster travel.
It's compact. The electron and positrons are closer together, therefore they're stiffer. And if they're stiffer, like that's part of the model of speed.
Yeah. It's very logical and very physically comprehensible.
Well, I was going to say, so you had on that last slide, you had the prediction by Simhony's Epola model, which is his ether model of space. So have there been experiments direct to this?
This is the first experiment that showed that this is what Simhony would expect.
Okay.
If you show that there's two paths, one away from the sun, one near the sun, Simhony's model said, well, the one that went near the sun ought to be slower.
Yeah.
This is the first data
So this
that
is the
came in,
data that confirmed
and it was misinterpreted by saying, well, I can't say light is different.
I see what you're
I'll
saying.
be
Yes,
fired.
and that's where they went to the time dilation. So yeah, because we've always said that prediction is the currency of good science.
Yes.
And he makes a prediction, it confirms his prediction, but instead of the secular scientists saying, hey, wow, this kind of predicted, it was predicted by Simhony, we're seeing what he expected. But no, Einstein's right. He's the Time Magazine's Man of the Year. The liberals love him. I'm going to lose my job. So time dilation.
That's right. And besides that, E equals MC squared.
Oh yeah, equals this. For more on that, you got to go back to the last show to find out why E equals MC squared has nothing to do with relativity.
Okay,
Awesome.
So deep space radio signals arriving too soon? Here's an AI overview. Pioneer spacecraft anomaly refers to the unexplained slight slowing down of the Pioneer 10 and 11 spacecraft as they moved away from the sun. What was happening here? Light was getting back from those spacecraft. Once they got past Pluto, they started, that light beam got here, that radio signal got here too quick. Why? What is wrong? Well, maybe the spacecraft slowed down and they're not as far away as they should be. But if they're far away they should be, well then light must be going fast. Oh, we can't say that. We'll be fired.
Yeah. And I wonder if the anomaly was too great for them to kind of explain it by the speed of that satellite, or what was this? The Pioneer.
Well, it took them, I think, from. Let's see. I think I have that maybe on the next slide.
Okay.
The
Pioneer spacecraft.
it took them like a decade to get far enough away to where you could finally see the speed was having an effect. So Pioneer 10 went in one direction. Pioneer 11 went in one direction. Radio signals were getting back too fast. Then they sent Pioneer 10 the other side of the sun. And guess what? All of a sudden the radio signals were getting back too quick again. I mean, we got double trouble here.
Wow.
And it wasn't just those. Voyager 1 and Voyager 2 had similar things. And Voyager 1 and 2 were built totally different. Some said, well, it might be the heat capacity of the heating elements within the spacecraft were heating one side of the spacecraft more than the other. And all of that was just saying, I don't want to get fired, so I'm not going to say it was the speed of light that was different. So they kind of brushed it to the side and said, oh, it's probably the heating element inside the spacecraft that caused it to deaccelerate. And that's why it wasn't as far as we thought. But if it was as far as he thought, it's following Simhony perfectly.
Exactly.
As you get out into deep space, the Epola is more compact. It's vibrating faster and carries light faster.
Yep. And you have to make excuses to try to defend special relativity.
And this is his book that I believe I've just now showed you is robust.
Matter, space, radiation.
Matter, space, radiation, invitation to the natural physics of matter, space, and radiation. This is Dr. Simhony in Israel. We held a meeting in Israel, in Jerusalem, to give him tribute. And I had the pleasure of giving him that plaque he's holding. And scientists from United Kingdom and the United States, about 50 of us met. We had a dinner for him. We had PowerPoint presentations of his theory and how all of us are working hard to see and advance his theory. And he accepted the plaque. He almost had tears in his eyes at one point here. Someone finally recognized him, because anybody else, if he was working for them, they'd fire him because he went against Einstein.
Yeah. Yep.
And so this is the book that I believe comes closest to totally replacing the theory of relativity. Get back to a real ether with real particles, with real calculated speeds, and you've done it.
Wow.
Okay.
I will mention the derivation of G was the one thing he didn't complete before he passed away. I'm working on that, and I wished others would take a look at it. That, I believe, is buried in his model. You put the math to that model, you should be able to derive the actual value of G from that model.
So our challenge to the audience, if you're watching this show, you made it this far, and we hope you have, because there's been some great stuff. If you can derive the gravitational constant using the mathematics that Dr. Simhony started. Simhony. Real Science Radio, I'm pretty sure we could get our audience. We've done it before. And even crowdfund or whatever we need to do. We'll do what? We'll throw in 10 grand if you can come up with.
Well, wait a second there, Fred. Wait.
I would put up part of that.
I would put up part of that.
And
hold on.
Yes.
Hold on, guys.
Yes.
Now, haven't we already confirmed that Simhony has already correctly predicted the distance between the particles?
Yes, he has.
The 4.4. Okay, so I think that anybody who's good at math, they've already got too much of a gimme on that. They're going to be able to figure this gravity thing out easily. So I don't know if 10 grand, that might be too much.
I will tell you, I've been working on it for about 3 years. It's not as easy as you might think. And I think I have probably as good an advantage to figure it out. But there are some really good guys with calculus, differential equations, Laplace transforms, you name it. I think there's some bright guys. However, on the internet, they will tell you, G is the biggest mystery presently in all of science. It is the low-hanging fruit, in my opinion, that's ready for picking. Now, the question I have on the screen is the theory of relativity. What will we do with it? Embrace it or replace it? And I suggest, as Christians, we ought to be working to replace it.
Absolutely.
Amen.
And what you presented today is, it explains all the things that special relativity, because friends of mine who are really big believers of special relativity, they're like, oh, look at all these predictions. Look at the Mercury periphelion. Look at these celium, the atoms and the vibrations and how you see different speeds. And, you can go on in these different predictions. Well, this explains it. And I was thinking about, while you're presenting this, I used to work for Trimble, and I was the team lead for their GPS division for heavy highway equipment. We used to build this device that would track the big Caterpillar tractors, because people actually steal those things. I don't know how they get down the highway with them. Those things are huge. But anyways, and track, where employees are working on their equipment within zones. Well, GPS, there's this myth, and I brought it up before in prior shows. There's this myth that somehow GPS supports special and general relativity. That was never true. The way GPS works is you've got ground stations that have run proprietary government software that synchronize those clocks every day. And all they did was they sent up satellites with a fudge factor, a digit, a number, to just a slight fudge factor to account for what I suggest is the Epola, because there are, these things are going to affect the ability for signals to come back. But if you account for that, with one fudge factor, you don't have GPS supporting relativity. It never has. Ron Hatch was a pioneer of GPS systems. He has many patents to his name, and he was vocal and adamant that stop saying that GPS satellites won't work without special relativity. They do not do mathematics on those satellites for relativity. That's too complicated. I mean, imagine writing the software and the amount of time it would take. It doesn't make sense. And I just know from my experience that these satellites are they've got a synchronous clock sent to them all the time, and that's why they never get out of step. And then they got the fudge factor.
So it's not related to the theory of relativity. It's similar to E equals mc squared. It's said to, but really isn't.
Exactly. Yeah. And this would help explain, we do have, a case where you can say that clocks, not time, can run a little slower up in this ether.
Yes.
And you get it here, you have less effect on the clocks, and it'll run a little bit. Or wait a minute, it's faster in space?
It's actually, when you get to the ether in space, the ether is more compact.
And so it's faster.
So the speed of light goes faster. However, with a cesium atom, its vibration is what they're doing.
Yep.
It can be just the opposite, but it's actually caused by a different gravitational field is messing with the vibrational motion, not with time.
Exactly.
You're in a different environment, and you
you're-
haven't considered it.
And if you're in motion, velocity, that affects it too. It's affecting the clocks, like you talked about earlier, not time itself. Time isn't relative.
They say the clock runs slower at those high altitudes and in travel. And what we're saying is they may run slower. They very well may.
Yeah.
But don't confuse the measurement of time
Exactly.
with absolute.
Amen.
So run slower with velocity, and then run a little faster, with less gravity. And then there's like a 38 microsecond difference. But we account for that again with synchronizing those satellites. We don't have to do relativistic math.
So fudge factor works just as good.
It
right?
works just fine.
Better, probably.
I challenge anybody out there who disagrees with me. If I'm hoping that you're an engineer who still works in the industry, there's this code that actually computes, does something with the relativistic equation. I want to challenge you to comment out that code in your receiver and provide us the data. And I'm telling you, you're still going to be within 3 meters of accuracy. It's not going to affect your accuracy at all, because the key is it's the synchronizing of all those satellites. And anyways, I'm going off on a tangent.
All right. And now let me rein you in, Fred, because I want to let the audience know that I had my tongue firmly in my cheek when I said there was too much of a math gimme, because I don't understand the math. But I do want to suggest that it's quite possible that the reason G gets figured out, it's not going to be related to someone thinking about math. It's probably going to be related to someone thinking about God, and it's going to help someone who knows the math. I'm just going to make that prediction, and it's going to be a result of, and I may be quoting Einstein, thinking God's thoughts after him.
Yep.
I believe that's actually Einstein.
I think I showed you why God favors Christians. So whoever figures it out, God, I think, will favor them to figure out this is the foundation of the whole universe. And this G value is the last remaining big mystery. And I believe it'll be a Christian that figures it out.
Well,
it doesn't have to be me. I'll let somebody else be famous.
Yeah.
I just want to see it done.
Well, we hope it's you, because then you were on Real Science Radio. So I have to ask you, are you familiar with Dr. Rupert Sheldrake? We had him on the show in January, and he had this great episode on TED TV, or is that right, Doug? TED Channel or TED TV? And he presents this evidence of how the speed of light slowed over time, and it confounded scientists because they didn't understand it. And they were, the measurements, they weren't, a lot of them weren't disputing the measurements. Well, anyways, eventually they just tied the speed of light to the meter, so you could never ever detect the speed of light change again, because they tied what you measure it with to, And so that was a real interesting show, and just the documentation of how the speed of light has actually decreased slightly over the years. So we had a show on that. And then we've also talked about plasma cosmology, and the real interesting thing that Setterfield has that we still want hopefully someone in our audience could try this. He's got evidence that the quantized redshifts that we see in space, that those match the electron jumps. The quantized electrons are quantized around those. The ratios match. And so if that's true, that really explains distant starlight, and it really helps with the idea of plasma cosmology, 0 point energy. Anyways, those are all fun topics. We're going to have a show on plasma cosmology in the future. Have you looked at all into plasma cosmology?
Not much. I did get his book, Setterfield's book, looked at it a bit. I am not real conversant in that area, but it sounded very interesting.
Yes, yes. Fantastic. Now, before we go, I want to just plant this in your mind, Dr. Moore. One of the things that always made me suspicious of relativity is that relativity asserts that the universe has no fixed direction. There is no center of the universe, right? And there's no north, south, east, and west. It's just something we perceive because we're on this ball.
There's no preferred inertial frame, according to that theory. So there's no center of space. There's no preferred spot in the universe.
Right, right. So let me just quote the sons of Korah from Psalm 48. Great is the Lord and greatly to be praised in the city of our God, in the mountain of his holiness, beautiful for situation. The joy of the whole earth is Mount Zion on the sides of the north, the city of the great king. So God dwells in the sides of the north. So when you said that the electron and the positron, they have a north-south pole,
yes,
it just reminded me of the Bible. It brought me to Psalm 48. And so we're not directionless. We're not floating through time and space and history without any direction. We came from somewhere. We are somewhere. We're going somewhere. The Bible tells us where that is. And Christians who know the Bible and think about mathematics and science can tell us more and more about where we actually are and what everything actually is. And that's exciting. And Dr. Moore, just cannot thank you enough for coming on and helping me to understand this better and bringing me closer to God as I realize his book agrees with so much of what we observe in science and mathematics.
And I want to thank you, Doug and Fred both, for allowing me a small platform of time to even discuss this.
Yeah, absolutely. I mean, we've been planning or wanting to do a in-depth show on relativity for years, right, Doug? We started talking about it, maybe 3 or 4 years ago, and just kept it on the production schedule and kept it there. And then finally I ran into this email about this guy named Dr. Pete Moore, and he mentioned something about relativity. So it piqued my interest, and I found out you've been studying this for years.
Yes.
It's been a passion of yours. So what a blessing it was for us to cross paths in I think even unrelated topic. I think it had to do more with the hydroplate, but somehow something came in there about relativity. I'm like, oh, hey, what's your opinion on that?
Well,
so God brought it together,
It was.
Amen.
Well, Dr. Moore, again, what a privilege it was to have you here talking about special and general relativity. And you've issued a challenge to the creationist community, try to solve G using Simhony's model. And you've provided a good substitute for it. And we have to decide, are we going to discard relativity or continue to embrace it? And I think it's time to discard it. We know it's an uphill battle, but you've presented some really good evidence on a competing model that explains everything that's thrown at you to support special and general relativity. So thank you for that.
And people can start by ordering his book online and diving into his explanation of the math and how he discovered the Epola. And I am hoping that there are Christian young men that are listening to your show that will be challenged and will say to themselves, I'm pretty good at math and I am a Christian.
Yeah.
I do have an advantage, and go after it. And let's see the next big discovery with a big green C put on their name.
Amen. Now, before we go, Fred, I do want you guys to know that I fully support the $10,000 award that I will also contribute to. That, by the way, if you solve it, you'll get the award from Real Science Radio right away. We'll send you that check really quickly. Now, I'm not sure what the Nobel Prize is. That like $1.2 million still?
I don't know. I just know from last show that Einstein's wife got all that
I
money.
was going to say we could ask Einstein's ex-wife, but here's the thing. The thing about the Nobel Prize with a discovery like this, probably won't get it until after you're dead. With the Real Science Radio Awards, you're going to get to enjoy that money now. So get to work on that.
Work for a secular university, you might get fired.
Yeah.
And that's a reality.
Sure. Yeah.
Yeah.
So, all right. So, for Dr. Pete Moore and my co host, Doug McBurney, I'm Fred Williams of Real Science Radio. May God bless you.